Ethylene, a widely used chemical, is traditionally derived from fossil fuels, posing a serious threat to the sustainability of our planet. In Indonesia, the industrial sector alone demands approximately 1.37 million tons of ethylene annually. However, the current domestic supply, primarily from PT Chandra Asri Petrochemical, only reaches 860,000 tons per year, highlighting a significant supply gap. Amidst this challenge lies a promising opportunity: the abundant availability of palm kernel shell, PKS. In 2021, Indonesia produced an impressive 3.3 million tons of PKS. Notably, the southern region of Sumatra, rich in this biomass resource, presents itself as an ideal location for establishing a green methanol plant. With a regional output of 1.4 million tons in 2021 alone, South Sumatra offers a reliable and sustainable feedstock supply to support plant operations. As the world seeks cleaner alternatives, the development of a sustainable ethylene production pathway becomes increasingly urgent. Conventional ethylene production through steam cracking emits approximately 1.5 metric tons of CO2 for every ton of ethylene produced. Globally, this equates to over 260 million metric tons of CO2 emissions annually, representing nearly 0.8% of the world's total carbon emissions, which were estimated at 34 billion tons in 2020, according to the Global Carbon Project. Fostering a greener future necessitates the presence of supportive regulations. The Indonesian government, through Presidential Regulation Number 16 of 2011, actively promotes the reduction of greenhouse gas emissions. These initiatives are aligned with the global commitment of Paris Agreement, particularly emphasizing SDGs such as 9, 12, and 13. Ethylene is a primary raw material that can be used as a raw material for various products, but to produce ethylene is currently generally done from the cracking of naphtha and coal. One of the potential raw materials is biomass in the form of palm kernel shells, which is a byproduct of palm oil CPO production. Currently, the utilization of oil palm in Indonesia still focuses on the production of crude palm oil, CPO, which has a high demand in the global market. In the process of processing fresh fruit bunches, FFB, into CPO, various types of waste are generated, such as solid waste in the form of empty bunches, shells, and fruit fibers. Until now, solid waste, especially palm kernel shell, has not been optimally utilized and is still considered as waste by the industry and the surrounding community. In fact, PKS waste has great potential to be reused. According to BPS data, in 2021, Indonesia produced around 3.3 million tons of palm kernel shell. This poses a major challenge for national biomass waste management. One solution being developed is to convert palm kernel shell into synthesized gas through gasification technology, a step towards more sustainable renewable energy. The stages of the ethylene production process include the formation of gas synthesis through biomass gasification, syngas conditioning, methanol synthesis, ethylene synthesis, ethylene purification. The CO2 content in syngas will be reduced using absorption technology with 30% MEA solution that can be recycled after utilization as an absorbent. The gasified syngas is reacted in a fixed-bed multi-tube synthesis reactor using copper-zinc oxide, aluminum oxide catalyst at 100 bar and 250 degrees Celsius to produce methanol. The methanol, with the pressure and temperature set, is fed to the ethylene synthesis reactor. In this process, ethylene is formed by the catalysis process using SAPO-34 catalyst in a fluidized bed reactor circulated with operating conditions of 3 atmospheres pressure and 450 degrees Celsius reaction temperature. This innovative process opens up transformative opportunities in the production of green ethylene to significantly reduce carbon emissions. This success is underpinned by a collaboration between supportive policies, advanced gasification technology, and optimized refining techniques. The journey from palm kernel shell to green ethylene is an important milestone in realizing a more sustainable and environmentally friendly future.